I'm Julia McQuillan, and I'm a sociology professor, and I'm also a principal investigator on the Worlds of Connections. And we are with RADAR, the Rural Drug Addiction Research Center, and the Department of Sociology. Super excited to have Zach Almquist here today. He's coming here as an assistant professor from the University of Washington. But before that, he had some other positions. And one of those positions was at Facebook, where he was a research scientist for 2 years. And I know that a lot of our graduate students, that's very exciting to see someone who's worked in an applied setting. And I think maybe some of that experience is going to be relevant to his talk today, where he's going to be talking about using Facebook to survey folks who experienced a disaster. I'm also very excited about his work with big data, computational methods, demography. He studied sort of methods and content areas like homelessness and migration. And I've followed his work on social networks for several years. I'm really excited about the software programs as well. So we'll have some more chances to talk about that later. And so I'm thrilled that you're here today to talk about your work, and I'm going to just let you jump in and let people ask questions later if they have some more. So go for it, and I will mute myself.
Thank you, Julia. That was a great introduction, and I'm really excited to get a chance to present my research here. So as mentioned, I'm going to talk about using social media to measure evacuation responses to natural disasters. First, I just like to get us all on the same page. I always think that's nice. I'm going to talk through some basic motivations. Why do we care about this problem? I'm going to focus on data sources for information on displacement. And then I'm going to talk through this case study, Australia bushfires, 2019, 2020, and then sort of like try to summarize everything up and talk about future directions. All right, so first, basic motivation. Disasters are these big events, right? There's a fire or a tornado, hurricane, tsunami, big destruction, people get dispersed. People's movement can be all over the place, where they go, who goes, what, whether it's more vulnerable or less vulnerable people who get pushed around and why. There are lots of sort of open research questions as sort of practical practitioner questions. And so the data and knowing what's going on is both can be needed to be immediate as well as sort of long-term. All right. So just a brief reminder on sort of key things that lots of NGOs and various other groups do. They try to distribute relief supplies. They'll set up Wi-Fi hotspots. People try to estimate communication, what's available, set up collective drives. All of these things require a general sense of who moves, where they move, and for how long, and general properties around them. All right, so this leads to the basic question of how do we get information? So the classic way to do this is interviews. More recently, geolocated data and administrative data has been used. Social media data has been used. Classic surveys have, of course, been around a long time in this area. However, combining them with social media and combining any of these like combinations is where I think a lot of the future growth is methodologically. All right, so first, just let's talk about interviews. Pros can be done pre-post, can provide an in-depth report of individuals' disaster experience, provides crude estimates of impact numbers, although these generally are not too trusted. And it's maybe one of the most common strategies for immediate post-disaster survey work. The advantage is you can have a team of well-trained people that you can deploy immediately after a disaster. However, maintaining such a team can be very expensive. It can be a very biased group of people that you interview. It can be small N. Generally speaking, the estimates that you get of the population and subpopulation are, less trustworthy just because you're taking a convenient sample. But this is a common and great way to get information post-disaster and has been a very ongoing area of research, and I expect it to continue going. All All right, so geolocated data. This is one of those new data sources. One of the big pros is that it's pre and post design by design. So you have data before where people were living and then where they go to after the disaster hits. It can provide very cool mapping tools. It can be used for deployment of resources. Sometimes it can even be combined with user data to get estimates of basic demographics, think age and gender. And it can be aggregated from lots of sources. During COVID-19, right, we've seen a lot of this. The SafeGraph data has gotten really popular where they're aggregating location data from cell phone apps, IP addresses, etc. What are some of the cons? Data limitations. Oftentimes we don't know demographic data. Oftentimes individuals can't be really disaggregated. We typically or rarely have any economic data. Data can be very noisy. Usually requires complex algorithms to use and can be limited to the set of people who have geolocation data, but is a very promising and neat data source. With that in mind, I want to talk about Facebook disaster maps. Facebook disaster maps has some relationship to the survey work I'm going to talk about towards the end of the slides. So it's good to have sort of a sense of this work. And it's a really nice example of how this geolocated data can be used in this sort of environment. So this sets up the basic limitations, right? It's only the Facebook population, although that covers a lot of people. It's movements between, geographic spaces. It can take into account to some extent connectivity and power availability. Right now, the tool is limited to what they call long-term displacement. This means that the people have to be gone for more than 3 days. The algorithm they use to detect whether a person has moved from their location requires that people be gone for at least 3 days. But it provides these nice sort of temporally causal events. They're privacy protecting and they're pretty accurate. All right, so this was all motivated by the 2010 Haiti earthquake, asking the question, can Facebook data be used to provide NGOs quick response data on displacement all across the world shortly after a disaster? So what data did Facebook have on hand? It has location history data. There are some key limitations to this. It's an opt-in setting, so people have to voluntarily choose to allow Facebook location data. But when they do, it's high frequency, high precision data similar to GPS data. It's enabled for about 15% of the Facebook user population. Facebook, however, only maintains it for about 2 months. So it can only be used very immediately after a disaster. However, they've started to maintain the anonymized aggregated data for researchers as part of the data for good. So people interested should apply to get access to that. So basic sense of the methodology, how does this work? They track basically where you sleep at night for several days before, and then look to see if you move for several days after. One of the issues you might be concerned about is vacationing, and I'll talk a little bit about that in a minute. All right, so what does this provide? This provides a nice bipartite matrix of people going from one location to another. They do what like the US Census Bureau does, which is if there's too few people to guarantee privacy, they just don't report the data. So it's got to be movement of more than 10 people. And they've built a very cool GIS software to interact with this disaster maps data, where you can pull up this like GIS suite and you can look at where people have moved, how many, and they even provide certain demographic breakdowns like gender. All right, so let's talk through just briefly a concrete example, Cyclone Fani. This was a massive disaster, 89 fatalities, over $8 billion in damages. Authorities report more than 1.2 million people displaced. So using disaster maps, you can see what cities people moved to, which ones received sort of the most evacuees and which ones received less. And you can see how quickly people returned over time, at least for that 15% of the Facebook population that has location history turned on. And so one of the like quality checks the team did to figure things out, to make sure that it was working and interpretable as proposed, was they looked at Memorial Day in Georgia, where you can see that vacationers has this very like uniform pattern compared to the disaster, which has this very like structured movement and these like nice smooth curves. So it does seem to work very well, and it provides very quick data for the IDMC and other sort of groups that want to deploy resources very fast, but don't have the money and access to like federal location data information. All right, now I want to talk about another important data source, administrative data. This has been growing in use by researchers. This is much more of a kind of like long-term kind of process. It's very much pre-post by design. It can cover large portions. So for example, the IRS migration data covers every county in the US. It can be free, and it can be relatively complete geographically, which has a lot of advantages. It's typically time limited, so the IRS data is obviously yearly. Census data to get spatial resolution for disasters is typically needs to be aggregated at about 5 years. However, there's other administrative data available, but it can be quite expensive, or you need to work with something like the Federal Reserve. This is the consumer panel data that looks at credit card usage. So let me talk a little bit about each of these cases. Fussell et al. Has looked at recovery migration post-Hurricane Katrina using the IRS migration data. So they had, where people lived before Katrina, where they spread out after, and then when they returned. So very cool pre-post kind of data. More recently, DeWard has used the consumer panel data for this more immediate micro level recovery post Hurricane Maria. So this sort of administrative data is also pretty cool and is more continuous than like the IRS data. All right, other new data coming online is social media data. This is pretty cool. This is of course related to the larger talk here. It's very much pre-post by nature. It allows for very rich retrospective analysis, so you can get access to text data, location data, pictures, so forth. It can be combined with geocoded data to make flow estimates. It can be combined with surveys. The basic cons, it can be a bias sample. The people must have Twitter. It can be a convenience sampler, those who tweet or those who geotag their tweets. And overall, it definitely tends to have the typical online bias, these younger, wealthier individuals. All right, so there is a lot of really neat work in and around looking at using social media data to understand post-disasters. Work by Martin et al. Using geotag tweets to track population movements to and from Puerto Rico after Hurricane Maria has some very cool work. And then they further extended this to leverage surveys, so surveying via Twitter and using that to augment some of their more classic address-based sort of samples. Still can be like relatively expensive strategy, but solves some issues that they were worried about. Very cool. Emilio has been working on a number of different ways to use social media data for migration. In the case of disasters, he's looked at using the Facebook marketing API for population movement. Notice I could have put this in the administrative data, and I think that's a really important thing to be aware. This is really administrative data for marketing purposes from Facebook. So they paid for access to this marketing API and then used it to estimate population movement. So it has the biases of the Facebook population, but it provides much more continuous movement patterns than things like the American Community Survey, and seems like a very cool future resource and is sort of an ongoing project by this group. All right, so now let's talk about classic surveys. All right, so pros can be pre-post, can be structured or semi-structured or even unstructured depending on how you set it up. There's lots of different ways to administer surveys: in person, paper, pencil, phone, online. Can be used for population estimates if you build the sampling frame well. It's sort of like one of the classic go-to social science tools. The cons in this sort of environment is that it can be really hard to locate people. So building a comprehensive, good sampling frame can be very difficult. It can also, depending on what mode you're using to collect the data, can be very expensive. And the administration options can impact your results in a lot of different ways, and both cost and like who you're going to get in the survey. Surveys also unfortunately have certain time frame issues. So for example, if you're surveying in India and you're looking at, say, flooding disasters, there are parts of India where they have floods almost monthly or even like weekly. So if you're asking about a particular flood, people can get a little confused. All right. The like big piece of research that I want to talk about here is this combining social media with administered surveys. All right, so the pros, again, it can be pre-post, it can be combined with other survey frames, it can be launched very fast post-disaster. One of the really nice advantages is it can provide a sampling frame that follows respondents because it's based on accounts. And it can provide a very natural probability sample that can be reweighted either to the online population or, based on some new research, probably weighted even to offline populations. So it has a really well understood sampling frame, which is pretty cool. Cons, it obviously requires internet access, it requires a social media account, and it can have sort of the standard internet biases of age, gender, wealth, etc. All right, so let's talk through an example that I'm intimately familiar with, the 2019-2020 Green Wattle Creek Fire in eastern New South Wales and the Cuttle Creek Fire in Adderley Hills, South Australia. All right, so this survey was administered in-app through the Facebook internal survey infrastructure. This is very similar to Qualtrics or SurveyMonkey if you've used any of those softwares. What it does is a banner pops up at the top of your Facebook feed, asks if you would like to take a survey to help out the social good project. And people have lots of options to opt out of the survey. They can always stop taking the survey at any time. And we ask a bunch of questions about their displacement experience as well as their experience in the disaster region in general. All right, this was a fairly complex survey. It did take somewhere between 5 and 10 minutes. we ended up not being able to do we can't do too much micro-targeting. So we did have a filter question to verify that people were actually in the disaster zone. And then we also had a big worry that some people missed the disaster because they were on vacation. So we did have a series of vacation questions. And then we asked a bunch of displacement questions, economic, transportation, early evacuation, etc. You'll notice that we ask focusing on more than one night and then 3 nights. The key with the 3 nights is the interaction with the Facebook disaster maps work. As mentioned before, disaster maps can only tell if people have been displaced for more than 3 days. So we did want to do some validity checking, and that's sort of one of the like future projects. All right, so one of the things to really get a sense of is how well does this work for sort of representing the Facebook population and then the Australia population. So it does a very good job representing the Facebook population, very similar percentages, except with a few more over 18, which isn't unexpected because we only surveyed people older than 18. So this is just representing people's movement over the age of 18. One thing you'll notice, and I think this is an important thing to call out if you haven't worked with a lot of social media data, is that women are typically represented compared to males, at least as far as people typically identify. And notice this is in comparison, of course, to the larger Australian census data, which is more even in the closer to 50-50 sort of range. The population is younger than the general population. And this shows up in a couple key ways. It's younger, obviously, in having more like 20 to 50-year-olds, but is especially transparent if you look at the 60 to 69 and especially the 70 plus. So there are a lot less 70 plus users on Facebook, and this shows up also in our survey. So it is a like slightly younger population, but not wildly off. So generally speaking, this is pretty good, I think. All right. We did a bunch of comparisons across other sort of core demographic, education, economic kind of things. So one thing we looked at was household size. So our sample underestimates the representation in our sample is a little smaller for one household's 12% versus about 16%. Our sample is a little more educated. So we have more graduate students taking the survey, or people with graduate education. And we have a little less people with just a junior high kind of experience. One thing that is a little complicated is the way we asked the high school community college type questions wasn't quite tuned correctly for Australia. If you combine the two, you see that you get approximately the right percentages. So we get a little more high school community college graduates than the general population, but only by a couple percentages. This has to do, with Americans writing a survey for Australians. Employed, generally speaking, the survey was slightly more employed, so 57 to 51%, slightly more student, a little more than a percentage over, slightly less retired than the general population. That is the getting less than, having less of the 70 plus year olds, right? And this shows up in this sort of retirement piece. And we have slightly more people not working than the general population. All right, but overall, pretty good, right? For for a sample that is just reweighted to the Facebook population is not wildly off. And that's like really important thing to know. All right, so I want to talk through another sort of like validity check we did. So we found that about 25% of the people were displaced more than one night. And so one of the nice things about having a population-based sample is that we have, or a probability-based sample is that we can use classic Horwitz-Thompson estimator to estimate totals for subpopulations. So we can use this fairly directly to estimate the number of people we think total were displaced. So we have an estimate of the proportion displaced. We just need to estimate the N, the number of people. We can pull that from the census. So combining that, we estimate that about 17,973 people were displaced with a 95% confidence interval ranging from 17,700 to about 18,200 people. And to sort of get a sense of how realistic do those numbers look, the International Displacement Monitoring Center estimated from Red Cross data that a lower bound of displaced population is about 17,000. So we're estimating more, about 1,000 more, but this is basically well within sort of reasonable given other people's estimates. And so this, I find this very promising. This is pretty exciting. All right, so I just want to talk through some other basic results. All right, so we ran a bunch of regressions. In this here, for example, it's the odds ratio for not being displaced versus being displaced. And the big takeaway from this regression analysis is that sort of the middle-aged, wealthier people are less likely to be displaced, and the younger, poorer people are more likely to be displaced. Not a wildly crazy finding, but at least consistent with the literature. Sort of the next set of slides are going to be very much in kind of a descriptive vein. I think this gives a good sense of sort of information you can pull from surveys like this. So where did you go when you left your home? We see that about a third of the population just moved around in the city. About 2/3 of people displaced went to different cities, but in the, basically in the same region. This is like staying in the same county or area. A small percentage completely left the state, and an even smaller percentage left the entire country. But we can kind of pick up the whole distribution, and we can pick up differences by gender, at least self-reported gender. So I showed this slide earlier. We see that about 40% of people who are displaced were displaced less than a week, but a non-trivial amount were displaced about 2 weeks, and a non-trivial percentage were displaced for a month, and at least 10% appear to continue to be displaced at the time at which the survey occurred, right? And those are the people probably most likely to end up being displaced long-term and not coming back home. So if you're interested in sort of the larger migration question, that's sort of a upper bound there. We also asked a series of policy relevant questions, some transportation questions. I think this one's particularly interesting, although this is, of course, pre-COVID. I suspect people's knowledge of masks has skyrocketed since this survey was conducted. So we asked the question of, did you have access to a mask for wildfires? And so there is this statistically distinguishable difference between males and females. And of course, the observation that only about 30% of people did have access to a mask. And then for people who had access to a mask, we asked the question, did you know like how to use the mask properly, the quality of the mask? And again, we see these stark gender differences, and this observation that less than half actually know how to use the mask or feel comfortable using the mask in this environment. Hopefully that has, of course, changed in the current environment. But these sorts of like findings can be like pretty useful. All right, so basic summary. There are lots and lots of cool new data sources as well as classic data sources. So we have geolocated data, right? SafeGraph, Facebook disaster maps, cell phone data, all of these mobility GPS type data that are being aggregated and employed to understand people's movement patterns, for all sorts of things, but especially disasters. We have administrative data, right? People have done some really clever things with IRS data. There's even been some people who've gotten access to micro level IRS data. So you can do lots of very cool things there. You have things like the American Community Survey that provide yearly or 5-year estimates of migration patterns. And then you have these like, right, consumer panels looking at people's spending and using algorithms to estimate people who have been displaced or moved around. Disasters, like in Hurricane Maria in Puerto Rico, where they've looked at sort of the recovery, people returning back based on these consumer panel data. We have social media data, which is being leveraged, Twitter, Facebook, LinkedIn, etc. And so both the public use data and internal data is being used to estimate population movements and for surveys. And then we have combining all of these new data sources. So I just talked through combining survey with social media data, but you can imagine combining that also with geolocated data. And you can imagine, right, providing a really rich understanding of all the things that are going on as you have this like tiers of data. And I think there's a really exciting future in sort of understanding short and long-term migration. So there is, as hinted, a ton to do, lots of cool future research. I think one of the like things to come on is conjunction with geolocated data, like I just mentioned. I think quick response surveys post-disaster. So Facebook population, right, over 2 billion people covering, basically the whole world. They can get estimates of movements and properties of those people immediately post-disaster almost anywhere. And that can provide both lots of national NGOs, UN, etc., finer grained data quicker than they would normally be able to do. So lots of cool things to be done there by practitioners and for researchers. There's a bunch of pilot data along with the bushfire data that needs to be analyzed to kind of like further fine tune and hone in these surveys. Very cool stuff. And last, I want to mention there's a really cool sort of step forward that I want to do, which is working with the network scale-up methods, which have been shown to be able to estimate offline populations from online data. So this is very, very cool. And this study in demography was actually run out of collaboration with Facebook. So it definitely works with the like kind of strategy that I've been talking about today. So with that, I want to, of course, thank my collaborators at Facebook, Paige, Eugenia, and JW. And with that, I want to open up things for questions. Thank you, everyone.